Hi, my name is Catherine. This is a re-recording of a lecture I did earlier this week on 3D printing and 3D model creation. I'm also making this recording for friends of mine who teach this subject and never quite know what they should say when they're asked to talk about 3D printing and 3D model creation. So as with all my learning materials, you're free to take it and steal it and use it and make it your own, and I'll put the slide link in the description. All right, this course. This is a very elementary course on the overview of the 3D printing process, learning how 3D printers work, from exporting a simple model to printing your own. This is designed for the individual who is completely new to 3D printing and is considering their first prototype or print but not sure where to begin. If you've already done some 3D printing and already used a machine, you'll know pretty much everything in this lecture, and this lecture would be a little bit too rudimentary for you. But I'll be teaching everything you need to know if you don't know all that stuff. Your first print, we'll talk about 3D printers in general, and we will talk a little bit about places where you can get your 3D print printed and how to upload your file. Topics: introduction and basics, different types of printers. This was for the Skokie Public Library, so I'm going to continue to use their site as an example of how you would upload a print file to the cloud. Filament printers, MakerBots, are what we're going to be mostly talking about for the rest of it. Talking about files, settings, and then the last part is making your own models. And then I did a hands-on modeling exercise, which I will just do the overview of what I did and not do as an interactive portion. All right, about me, my name is Catherine. I've been making prints for over 5 years, but been working with the technology since it came out. Not when 3D printing came out, but when these little inexpensive consumer devices came out, I started working with them. But I am just a hobbyist. There's a lot of people who are a lot better at 3D printing than me. I just tend to be better at teaching it. I work with SLA printers at a makerspace, so I'll talk about SLA printers and resin. And then I make my own digital models for a video game that I launched last year. They were very simple models, but still it just kind of shows how with a little creativity and a little knowledge of modeling software, you can make some pretty spectacular things. I do start with what is a 3D printer because we're going to be talking about these consumer desktop 3D printers, but there's a whole lot to 3D printing outside of that. There's car parts that are being made with 3D printers. There's giant $1 million machines that are making huge things. There's lots of different types of printers. But a lot of times when you hear people talking about 3D printing, what they're talking about is these. Now, this was just a screen capture, so you'll notice there's a laser printer in here, which is not a 3D printer. The 3D printers we're mostly talking about in this hour are these plastic filament. They're about 2 feet high. Depends on how big they are. They're all different. But anyway, there's lots of popular consumer brands. MakerBot is the big one, but these Prusas are known as a high quality, inexpensive machine. You can put the kit together yourself, or you can order it ready to go. And then these Enders have been these inexpensive machines that a lot of people really like quite a bit. All right, I want to talk a little bit about types of 3D printing, basic categories of how a print gets made. Again, we're talking about plastic filament printers through a lot of this lecture. And so that is based on that you've got this melted plastic that's going through a little nozzle and it's building up the layers layer by layer on a bed. So again, melted plastic layer by layer on a metal bed, on a bed. Then SLA printers are my passion. This is what I've started getting into the last couple of years. So these are SLA printers that it's a light source when it selectively cures a photopolymer resin in a vat. So what that means is, so now if you notice the print is printing upside down. So this is the bottom of the print right here. And it sends this little platform down into this liquid resin. A light shoots the light onto a mirror, which again selectively touches a surface this surface property of resin. So there's this liquid resin puddle, and it touches the very surface of it, and where that laser touches the resin, it hardens. And so it does that with the equivalent of like 1 pixel, so to speak, at a time, and it makes a layer through that light, hitting all the spots and solidifying. Then the platform in this middle square moves up a teeny tiny bit. It's incredibly high resolution, and it makes another teeny tiny layer based on the light hitting a different spot on the puddle of resin. So, and then it lifts out of the water. And I've always loved the technology because it really looks like Star Trek when you see your translucent print coming out of a translucent lake of resin. All right, another type of printing I just wanted to talk about. Again, there's lots of types of printing. I've seen printers that do ceramic. There's printers that print metal. Again, there's industrial 3D printers. But the other way that printing is done that I want to talk about is these powder bed fusion printers, which is when you see a lot of stuff done in medicine, you'll see these. So again, so you've got a source of thermal energy, and it's hitting a bed of powder. So in these prints, your print comes out of a bed of powder. That comes incredibly handy when there's a thing called supports. Because if you think about this for a second, if this doesn't have a layer to build on top of, it will fall apart and plastic will ooze out of the nozzle. But when you have something like this, it doesn't need any support because the powder kind of sand texture supports it, and then you just lift it out of the sand as a complete structure. So those printers can cost hundreds of thousands of dollars. I am guessing when I say I think it's about $500,000 for one that's about the size of and they're huge. I've seen one that's like the size of a telephone booth. Okay, so I just want to talk about that there's more to 3D printers than consumer printers. So I never want to say when we talk about 3D printers, we're talking about some little 2-foot cube that costs $2,000 and is used in schools and libraries. This is the way that a 3D printer could be used to build a house. There are some construction companies that do this. And again, so if we talked about how the nozzle has plastic coming out of a plastic filament nozzle, then this has cement. So it's the same thing. I'll explain a little bit what this bar is and that the XY coordinates, but it's basically saying up, down, left, and right, depositing a layer of cement instead of plastic, going on a pattern, following it, and building up walls just like we build up walls with plastic printers. Same idea. The other place that we hear about 3D printers a lot, we hear about it in food production, which I'm not going to get into because I'm going to show you a cake nozzle with icing that kind of shows you that you can call anything a 3D printer. But I do want to kind of talk about hype with medicine. And I hear a lot of people talking about how they can print bone with a 3D printer. And the little bit I know on the topic is that what they're printing is a material that helps bone graft onto that material very well. But they are not printing bone per se. So if you go to your orthopedic surgeon and you want a disc made of your own bone printed on a 3D printer, they will turn you away at the time of this recording in 2020. So the lecture I did this week was for the 3D printing program at the Skokie Public Library, but I think it has some overarching principles of how to upload and how to find a place to print your prints for free that are worth talking about. First of all, if you're willing to pay a good amount of money, there's places like Shapeways that will make your print for you. But your local library may have a program. Skokie's is extraordinary. And if I may, I will take you to the site. This is their 3D printing program, and they have a 3D printing request form. And I only show this because there's going to be a moment where you're interested in 3D printing and you need to send your file to someone. And I want to show you that the principles of sending your file are the same as any other type of file. Like if you had a photo file, like a JPEG, if you're used to those, if you have a Word file, it's a doc. These, there's a few different flavors and formats, but for this site in particular, it says we only accept STL files. So you would just simply choose your file from your computer, and you would pick out the file, and upload it. And in this case, with Skokie Public Library, you would put in your name and email, and they have a limit to how much they do every month, but they would do your print free of charge. So I do want to highlight that program. I also want to highlight that program because when I was doing this lecture, we geared a lot of the questions towards getting started with these things. And so when we talk about file types and STL files, I'll talk about those later in the lecture because this lecture goes from kind of big to small, these big things about 3D printing, but then it gets into the nitty gritty of file types and some of the more tedious things that have to be dealt with. Okay. Plastic filament printers. Okay, so what I also attempt to do in this lecture is that I'm lecturing to a lot of people who've never seen a 3D printer in action so far. So they don't understand the basics of how the machine works. And so I'm assuming no presumed knowledge and explaining just from the beginning how these work. So this is the plastic filament, and I call it the spaghetti strands. So, and it is about a thickness, it depends on the type of printer. There's 2 different thicknesses of resin that I won't get too into, but you have your spool of resin and it goes into a machine like this. And somebody asked me the question that I realized a lot of people who are new to it don't know is, how does the machine know what to make? And the answer that is model files are transmitted from the PC to the machine. So what I will do now is switch to a video I made that I will do the voiceover and show how this works. I go through this very quickly, so I'm going to pause a few times as I go. But what I'm showing in this video is the workflow of if you wanted to download a ready-made, ready-to-go printable file from Thingiverse. So I start with the Thingiverse site and hit the download all files on what I've selected. Pick my spot on my computer, extract it, and that's where you do need to have enough computer skills to know how to download a file from the cloud and extract it. But once you do, you can find a 3D file viewer, like I have here. Open the file, and then you'll see this is the body of an owl. It's a simple print, and so we're going to see it in the viewer. And you can rotate it and look at it from a couple sides. So there's a few different types of software. So I always say like 3D printing gets pretty confusing pretty quick because it's very simple. You've got your 3D printable file and you just have to manage it like any other file. But in this case, if you're going to print it yourself, which is different. So if you're going to send it to a place like the Skokie Public Library, you take your file, download it to your machine, and you upload it to their system. But if you had like a friend or you knew somebody with, in this case, a MakerBot, you have to put it in the software that translates the file between a computer file and understanding the brand of printer you're going to be working with. So every printer needs some kind of slicer. That's what they call a slicer, because it slices the print into layers and generates a special kind of code that the machine can understand. That code is called G-code. So these slicers they give you a very intuitive interface. You import your file, you set up your settings, and then it conveys those settings to the printer. Things like how thick you want your layer, if you want some sort of platform on it to help it print better, if you want supports, which we'll talk about in a little bit. Those are all the things that you would convey in your slicer software that would go into the printer as it makes decisions about how to print your print. And so I'm importing it into the MakerBot software. There's lots of different kinds. There's also wireless systems that send it to it. So that was how to do something on Thingiverse. Then I also do teaching about 3D printing and modeling where we do things in Tinkercad, which we'll talk about Tinkercad in a little bit. But so here I'm doing the workflow of that you've made your own creation in Tinkercad, and this is how to export it and again put it into Slicer software and send it to a MakerBot. So you just export it. In this case, I picked OBJ as opposed to STL, and it's on my machine. I transfer it using a USB device, and then you can see, I'll just go back one step. So see right here where my mouse is pointing, that's the USB drive. So it has a USB slot right here, and that's where the file goes from your computer into the machine. So this is what we call the bed. This is the interface, the knob that helps you control the settings and the settings. So okay, so now we're going to get started with the printer itself. The first thing it has to do is it has to make sure that the filament is melting properly. It's going to go through that nozzle, and it's going to be the right temperature. It's just going to all work. There's a piece of the printer that we'll talk about in a minute called the extruder, and the plastic comes out of that. So the first thing you're doing is putting in your filament, which is the spaghetti looking stuff that's going to melt. And so you load your filament. What I'm showing here is that you can see the temperature is 109 Celsius currently, and it has to go all the way to 215. So setting up your printer and getting ready to print takes about 10 minutes just to get your print working. So it's just something people don't realize when they're going to make a 3D print, that there's a lot of waiting around and waiting for things to heat up and cool down. This is the spool of filament, and the filament comes out of the spool, kind of like a film reel, comes out there, and it goes through a connecting tube which connects to the extruder. So when you run out of your spool, you put in a new spool. And this is a very important part, that the tension of your filament, this is for those of you who are going to be actually doing a print someday. This does not aim to be comprehensive training on how to do a printer, but you can see some of these considerations. This is where you slice your filament at an angle, so it has that nice sharp tip. And then we're going to show that we're ready to load the filament. The Smart Extruder is ready to accept the filament. You take it, you put it in the little hole, and you feel it pulling it in. And eventually the filament comes out the other side as this melted plastic. And so you can see it kind of streaming out of there, and that means you've got a good flow going and your printer is working well. You can see it's dumping plastic all over the floor. That's me doing it with my hands and remembering that I'm doing this for the camera, so I need to cut it with the scissors. And your printer is ready to go. The first line that it does when you hit print is a thin test strip. This is where you pick your print. Again, it was on that USB file. And we're printing a doll head. And this is our painter's tape that protects the bed. But that is the extruder coming down towards the bed, getting really close to depositing that first layer. So you can see the first layer getting printed right there. So see, that's this test strip. And that's how the printer is making sure that everything is set up and it's ready to successfully print, starting with the first layer. This is footage of it printing. You can't get closer up to show the nozzle when you're doing this. Here's a little, I don't think you can hear the sound, but the printer makes some crazy noises, and that is the print. So that is the workflow of the 3D printing machine. So we can't do a live instruction to show people how to use a 3D printer, but we can at least show that video so you know what it would look like if you were there. All right, so this is the close-up of the nozzle. As I mentioned, you can't make a video of that nozzle coming down. So I do this, if you're ready. So this is my demo of what it looks like when a nozzle is extruding plastic resin close up. I use icing and this plate to represent the plate bed. But this is what's happening, and I explain this because I will show you how to design your design for 3D printing based on the physics of what happens. So the printer only knows a few directions. It knows front, back, left, right, up and down, and that's all it knows. So it's going in those directions, or a combination, to go in a diagonal. So it gets the direction to go to coordinate, X 125, 250. And then it's told to go downwards. So it goes downwards. and then it's told to go to the left, and then it is told to go to the right, and it makes its first layer and comes to a complete stop. Then it's given the directions to repeat that and move up a little bit. So it's moving up, so it has moved up, and it's deposited another movement, another layer using these same movements, and it makes a second layer. And that's how it builds up the print, but it has no artificial intelligence. So one of the tricky things about a print is if you say, I want to print this shape. I want a nozzle at the bottom, and then I want this stuff right here. Well, what it would do is it would print this, it would build up these layers, and then when it got here, it would deposit frosting onto the floor. It would think there's something supporting it, and instead it would just strip the frosting, and your print would be ruined. It would fail your print. So when you make a print with this kind of shape, you have to tell the printer to give you some sort of support, and it'll build in some supports, which I'll show you how those work in just a minute. But anyway, so that's the basics of how it builds layers without having any intelligence in the machine. So one thing we'll talk about with printers is that printers do not understand when they're printing in thin air. Getting files for printing. So we talked about Thingiverse. There's a site called Sketch Warehouse. TurboSquid comes to mind, Tinkercad Gallery, and so those are all places to get files. In my live lecture, I went through all those sites. I can do a quick thing of Thingiverse, but I will show that workflow in a minute. But I also want to say that this is where we're talking about OBJ versus STL and what kind of file type you do. The only thing I'll say about OBJ versus STL, they're the same thing. They're both 3D model files. However, OBJ has information about the surface. So if you model a truck and you're able to give it color in your software system, then the OBJ file would be something that could contain that information. Conversely, an STL file just thinks you're printing a one color print, and it doesn't have any information about the texture. You can't specify that it's a reflective surface or anything like that. So Thingiverse is an amazing site that we will just go to for a second. So there's a lot of magical things that you can find on these sites. People very selflessly design these things, load them up on the internet, and just let them be usable and remixable to anybody who wants them. So these puzzle boxes are little boxes that you put the lid on and get it secured to the bottom by going through this maze. And again, so this is where your print settings are going to be important, and you want a high resolution print or it won't work very well. But this would be the kind of thing that you would just, at no charge at all, download the files, send them to a printer, and then you would get a copy of that object. So downloading files, as I said, it goes to your printer. And I wanted to switch gears now and talk about supports, because I mentioned you need supports for your model. So again, we're back in our slicer. And so this is a very easy to print object. It just is a flat surface. There's no problems with this printing. This is very likely to be a successful print. But say for some reason, for the sake of your print, you needed to print it like this. So that would be very, very challenging for a printer. The printer would not be thrilled about printing a shape like that, because again, you can see where it'd be putting a lot of extra filament onto the bed and just dripping it down. So what you do is you're going to build in supports. It's kind of like a call for help. These supports are cumbersome and a little bit difficult to pluck off as of 2020, but this is the way it is done today. So you would specify that you want supports, and then I'll show you what those supports look like in the print preview. So those are your supports. So you can see that it would deposit a tremendous amount of plastic just to hold up your shape. So I mentioned failed prints, and this is a good example of what a failed print looks like. Again, when the nozzle has just been depositing plastic into thin air, it tends to look like that, and you can see that it's ruined. And you don't try to fix a 3D model, you just print it again. Okay, the final part of this lecture is what I spent a lot of time on in real life, but it's the topic of making your own models and prototypes. So as we talked about, you can go on different sites and you can download models, buy models, but it's funnest if you're interested and if you've got something you want to make, making your own models. So the rest of this lecture is pretty much dedicated to helping you understand the right software that you should learn to make your model. The reason I belabor this is that what I'll show you about these different software programs is that all of them are completely different. And if you learn one type of modeling software, you've literally learned one type of modeling software, and that will not help you at all when you learn a new software system. You will literally be starting over. So I'm going to show you a little bit about how all of them think about design differently, and how you would really have nothing that carries over from one program to another. You would have ideas about ideas like resizing a sphere, but how you do it, you'd have to learn in every single system. So let me start out with talking about the software that I use when I teach kids how to do 3D modeling. This is Tinkercad. Tinkercad is the simplest software that you can use. You need a login to start, but you can pick any object in the gallery. I'm picking something I made already, and I am opening a file. So this is the exercise that I do when I teach kids about 3D modeling, but I did a version of it for grown-ups. But what I want to show you, that I show kids and adults, again, they can log in very quickly, get an account, and get started. So all you do you're working with these very simple prefab shapes in Tinkercad. You're not changing the shape of things. So let's say we wanted to bring in a sphere and we want to make an ice cream cone. As I always teach everybody, when you click on the object, you can see almost an iconic set of directions. And so you have to learn that the Hershey Kiss means you pull it up. If you see these arrows, that means you rotate it, which won't look like anything because it's a sphere. These things here, resize it, and then you can rotate. So those basic movements of moving, scaling, rotating are in every piece of software. And that's about all they have in common. The next piece of software I want to show you is Autodesk Maya. This is what I've used the most, but again, I do video game design and my focus hasn't been on 3D printing when it comes to model creation. So, but I just want to show you the huge range of like the difference between professional software and children's modeling software. The demo I always do is the following. So I make a shape like this. And so I have my shape, and then imagine this as a pottery wheel. So imagine that we had this on this axis and it was spinning around and it would make a shape that would almost look like a vase or like a ghost. So you say surfaces, revolve, and it looks like that. And so, but I want to show you how, okay, let's turn this into a wireframe and move it to the side. And now let's go back to this original curve. And I just do this to show you how much control you have when you're working with these advanced types of software. So when you move the curve, you can revise your shape and do all sorts of things to reshape. So anyway, I just do that to kind of show the huge difference between dragging some objects in Tinkercad into this software that you invest in learning. There are tons and tons of buttons in Tinkercad. I always am showing that this is just one menu bar. So this is the modeling bar, and then these are the surfaces and the curves. It gets into sculpting, and then it gets into a lot of rigging and animation. The last one I want to show you, just to show you the difference of I'll talk about all of them, but the last one I'll show you is Autodesk Fusion 360. Other big brands are SolidWorks. For people who are engineers and the company supplies their software, a lot of them use SolidWorks. Unlike everything else that you can get a free license right now, SolidWorks is thousands of dollars. And then there's Blender and Rhino, which are also 3D modeling programs that have been around for a long time. So what I want to show in this video is, this is Autodesk 360, and I want you to look, it's a little difficult because the scroll bar is there, but look at where the scroll bar is, this section down here. I'll move my mouse out. But see that? Those are all the different steps that the model has been through. So what you can do in Fusion 360 is what they call parametric modeling. And I just want to explain this one concept because it's really a breakthrough concept as you get into more sophisticated shapes and you're getting into prototypes and prototypes that have to work and do exact measurements. But you would go back in time to this moment where you added this block in this way, and you can edit it and change it and then keep all the subsequent steps that you did this exactly the same. So you don't have to go back and do it again. You just go back to that step, revise it a little bit, and then all the rest of your steps take effect. So that's one of the huge differences between Fusion 360 and something like Autodesk Maya, or obviously a child's software like Tinkercad. The last thing I want to talk about is subtractive printing. I just want to say that everything we've been talking about with 3D printing so far is what they called additive manufacturing, which means you're adding layer after layer of plastic or ceramic or whatever it is onto a layer. Well, there's a type of printing called subtractive or subtractive carving, and that's the art of taking a digital model, again, just like we have with our OBJs, but instead it teaches a machine that can be like a machine called a Tormach, which is a carving tool. It will take a drill, it will go into your piece of aluminum, of a block of aluminum, and then carve everything away that isn't the shape that you're looking to achieve. So in this screenshot of this video, you can see people are making these 6 half spheres, and they put in a block of metal and it carved away everything that wasn't those spheres, and it did it through understanding the directions given to it by a computer generated file. So that is it. That is the end of my lecture, and I hope you found this helpful. I hope if you get put in a position where you have to do an overview of 3D printing for beginners, that this will save you some time in creating your own lecture. And thank you for watching, and I'll see you soon.